Now, the battery factor everyone misses. What is the battery factor and what do we miss? Each cranking attempt drops battery voltage significantly. Okay, what is voltage? Voltage means pressure of electrons. Electrons are pressurely pushed in the conductor and it is cranking the motor, starting motor. Okay, we have seen. It will significantly come down after some time. Even our power also comes down when you are doing same activity again and again. Okay, the same way it is also a what power or energy, it will come down significantly if your rest period is too short. See what happens, chemical energy in the plates are there, right? So chemical energy will generate the electrons as per requirement. At the start it will give boost. This is a special purpose battery. At start it will give more voltage and current to start the motor. Okay, but the electron generation should happen right that fast. So this chemical reaction takes time. Okay, that is why it needs also resting period. This battery also needs resting period. Otherwise we will not get proper pressure of the electron. We should wait up till this battery will generate the electrons. Okay, so the battery doesn't recover and subsequent attempts are weaker. Then after some time its power is down, the weaker attempt, okay, it will not last for 10 to 15 seconds, only small attempt. So again the engine will not start because it needs hard start. Okay, so 30 seconds recovery, 50% recovery minimum rest period for small engine. If it is taking 30 seconds, then 50% is recovery period. 60 seconds, 80% recovery recommended for medium engines. Then 120 seconds, 95% recovery necessary for large engines. So this is why large engines need longer rest period, not just for starter cooling, but for battery recovery. This is happening at the same time, this thing. Why the resting period? Resting period is not only for engine, it is serving for battery as well. Okay, so resting period is important between two cranks. First crank 10 seconds, then wait for 30 seconds so that battery will create the proper voltage, the engine will cool down. Then again for 60 seconds and 120 seconds. Now you understood why this is missed. Everyone misses the battery factor. Now, number of start attempts. How many times should the panel try to start engine before giving up? We have seen 3 times our hospital DG. Okay, and then it gave up, locked up. So the answer depends on your application's criticality. Again, there is a setting on this. How many times you should start cranking? 1, it is not starting. 2, not starting. 3, not starting, give up. Then, depending on load, life safety applications, hospital or emergency services, fire related services or hospital, start attempts 6 to 10 attempts we can do. Logic, keep trying. Life depends on it. As life is more important than this diesel engines, so we should keep on trying. Include manual override capability. Manual override capability is also important. If it is not starting, then manually you override and start it automatically if it is not starting. Then business continuity, data center or manufacturing, start attempt 3 to 5. This is the life saving. This is not. So 3 to 5 is okay. Then logic, balance availability with equipment and protection. Then protection is also important, but 3 to 5 is okay. Office building, 3 attempts, logic, protect equipment, inconvenience acceptable. Equipment protection is important. That DG said 3 times we have done, we have given it a try, but now it is not waking up, so just not try. We should check what is wrong with that engine. Then professional insight. What insight? More attempts isn't always better. Not better. This is not better. That is why 3. Stick to 3. Within 3 attempts, it should start. But then manual override, very important point. Manual override we should check, and then manually we should start it. After 3 failed attempts, the problem is usually mechanical, not electrical. So we keep on trying. We think this is an electrical problem, but mechanical problem can damage the modern communication and monitoring. IoT, Internet of Things. Modern AMF panels aren't standalone devices. They are part of integrated building management system. IBMS, Integrated Building Management System. Everything is integrated at one location and monitoring happens. So with advanced communication capabilities, Ethernet connectivity, Ethernet wire is connected. Okay, that blue colored computer cable, okay, if you have seen on your desk or computer is connected through that blue wire or your data centers, that is Ethernet connectivity. Modbus or RTO or TCP protocols. So these are protocols, means languages of different systems. What to understand after this signal? Okay, 0 and 0 and signals are there, and accordingly protocols are defined. Modbus is used for HVAC. Then RTO or TCP IP protocols are also used in fire or all other systems. BMS is generally on these protocols. So SNMP is also there. SNMP is used for UPS. UPS language understands that SNMP protocol. So email and SMS alerting. So this will understand and it will email and SMS to the user who is controlling that there is some problem in DigiSet or AMF panel. So it should email or SMS. Cloud-based remote monitoring. So remote location, like in deserted area, we should have this system, advanced system, so that we will get it on mobile, that there is some problem in that engine. Just it needs attention so that we can send the technician. Professional secret, always specify dual communication paths. 2 paths should be there. One can fail, another will take over. Primary Ethernet for normal monitoring. Backup cellular modem for emergency notifications. We should have modem backup, wireless. Okay, there are 2-3 types. Now, LoRa system is there. Then what 4G SIM card is there. Then what Wi-Fi is there. So these things we can use for modem for emergency notifications. Okay. Now, remote monitoring capabilities include real-time engine parameters. Real-time engine parameters, we should monitor the temperature, the pressure, all these things. Fuel level monitoring. Then maintenance schedule alerts. If maintenance schedule alerts should also we receive, otherwise we will forget. Okay, human beings are forgetful. Machines are not. It will alert you on time. And predictive failure analysis. Predictive vibration we have seen. If vibrations are more, it means something is going to happen with the engine. Okay, either bearing will go wrong. So we should know the predictive. Now, professional commissioning checklist. Now you have installed the AMF panel. While commissioning, what to check before we put it in normal operation? We should do the commissioning to check all the parameters, verify all the connections, check all the connection, use continuity tester. Continuity tester, don't assume connections are correct, don't assume continuity, you should check. Then test monitoring circuits, inject known voltages and verify readiness match expected values. Monitoring circuits are there, so you should inject the known voltages in that and you should check it's for normal operation, expected match. Then simulate mains failure. Mains you should simulate, you should fail it, okay, and you should start the mains, fail and start. Then it should act accordingly as per our time settings. It should take delay, it should, all the sequence should happen as per the desired. So use manual override, don't wait for real outage to test system. Just manual override from this thing auto and test it for the simulation. Time all sequences, verify delays match specifications. Every delay you should match and applications requirement. Test under load. Use load bank to verify full capacity operations. You should put on load bank so that we know at full load it works properly. So verify restoration. Test automatic return to utility power. Automatic return it should test. Document everything. Create as-built drawings and setting sheet for future references, because technicians will keep on changing. Okay, attrition is there. So these physical evidences should be there. Drawings and setting sheets. What was the setting before at this particular load? So those should be there. Now critical test. Always test the mains failure during generator operation scenario. When generator is working, at that time you should switch on the mains from the city power so that it should stop. It should give back load to the city power. Now why it is important? This tests whether your panel can handle utility restoration transients. See, we have seen in water also there are transients, waves are there at start, inrush. So at inrush current will be high. Then this resistance, we have seen the stones in the water current. Same way, this resistance is the stones in the water current. It will restrict the current flow. So inrush currents will be there, transients without dropping the load. Without dropping the load, it should sustain the transients. For that, delay is there. It will not put directly load on DG. So this is very important. DG should be working, and that inrush, it should sustain that. Otherwise, at the time of emergency, the inrush will damage our system and we will not have the emergency backup. So it should sustain. It should be like that. It should sustain that inrush current or transient. Now, key takeaways. Intelligent control, AMF, automatic mains failure. Critical timing is important, we have seen. Then quality installation. Quality is important, that transformer, okay, voltage or potential transformer. Then thorough testing. So these 4 parameters are very much important, okay, before we put that AMF panel into service. Okay, just remember that. So in this way, we have completed this entire module of AMF panel. Okay, wasn't it interesting? Yes, right? We came to know many things which are behind the scene. Okay, thank you.